So in general, if you look at n factorial, it's n, n minus 1, n minus 2, n minus 3, and it would keep going on for life. Because the factorial symbol means you go till you hit 1, right? Well, when you don't know what n is, you can't go till you hit 1 because you're not going to hit 1 until you actually find out what n is, so you just have to keep going. So if we have n factorial, you'd have that. If you had n minus 1 factorial, you'd start off with n minus 1, and then the next term would be 1 less, so n minus 2, and the next one would be 1 less, so n minus 3, and then it would keep going on forever, right? Because we don't actually know when we'd hit 1 if we don't know the n. So, example 1, simplify the following expression, leave the answer in product form where appropriate, do not expand. So if we have n plus 2 factorial and n factorial, our goal is to cancel off the factorial symbol somehow. And you'll see why when we get to the next page. Actually, when we get to the next question. So if you look at this, n plus 2 factorial and n, which one's bigger, n plus 2 factorial or n factorial? N plus 2. And if you don't realize that, I'll write it down here. N plus 2 factorial, if I expanded it, is n plus 2. What's 1 less? N plus 1. 1 less than n plus 1 would just be n. And it will go on forever, right? So n onwards with this dots, instead of putting these dots behind it saying it goes on forever, I could just put a factorial symbol behind it and get rid of the dots, correct? So n plus 2 is actually bigger than n factorial. So you want to expand the one that's bigger, and I'll show you why. I'm going to expand the n plus 2 up here. I'm going to get n plus 2, so equals n plus 2, n plus 1, and then n. And then it would be n minus 1. I could keep going, correct? You could go n minus 1, dot, 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 if you wanted to, right? If I expanded the bottom part, it would be n, n minus 1, dot, 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 right? Now, instead of writing it like that, n, n minus 1, dot, 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 I could actually erase this part, the n minus 1, dot, 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 and the n minus 1, dot, 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 and replace those with a factorial symbol, right? Because it just keeps going on after that, n factorial, right? So instead of expanding them out like that, I would just write them as n factorials, and then the n factorials cancel because they're common on the top and the bottom, and you're left with n plus 2 times n plus 1. That's it. With b, n minus 2 factorial, n minus 1 factorial, which one's bigger? N minus 1 is bigger, right? Because n minus 1, then it goes to n minus 2, 1 less, factorial, right? So n minus 2 is smaller, so I'm going to leave it there, n minus 2 factorial. And the bottom, I'm going to make n minus 1. 1 less than that would be n minus 2. And I could keep going, dot, 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 dot. But instead of keep going, I'm going to actually just go n minus 2 factorial. Does that make sense? Or am I losing people? You all look the same, no matter whether you're getting it or not. Yes? Okay. So the n minus 2's cancel, n minus 2 factorials cancel. When you cancel, you're actually doing a slash line through it, right? What does that slash line represent? In grade 9, in grade 10, you would have actually probably drawn a 1 in its place. Whenever you slash a line, it actually is a 1. So what am I actually left with on the top? Not 0. The top doesn't just go away. The numerator doesn't just go away. It's actually a 1. And then on the bottom, you'd have n minus 1 times 1, which is just n minus 1. And that's it. C, the only thing you can do is try and expand the top because the bottom doesn't have factorial symbols. So I'm going to expand the top. It's going to be n, then 1 less, n minus 1. And I'm going to go one more to n minus 2 factorial. The reason why I'm doing that is I can't just stop at n minus 1 factorial and then cancel the n and the n minus 1 off and just have a factorial symbol sitting in the numerator. That doesn't work. The factorial symbol is attached to something. Okay? So I can't just go n minus 1 factorial and then go n minus 1 on the bottom, cross off the n's, cross off the n minus 1, and have a factorial symbol standing here, right? So I actually have to go one more. That's why I went to n minus 2 factorial. And now I can cross these off. I can cross these off because this is just n minus 1. I wouldn't be able to cross an n minus 1 factorial with an n minus 1. They aren't the same, right? So that's why I have to keep going. And so it's n minus 2 factorial. Now the reason why we do that is so that we can do questions like example 2. So this is actually the NPR formula. The NPR formula is NPR equals n factorial over n minus r factorial. So what you're actually doing here is you're saying I have n items and I'm picking 2, and that would equal 42. That's what this formula actually is. They just filled it in for us. Okay? And they would ask you how many, like, so this could be I have X number of letters, I choose 2, and I end up with 42 different words. Well, how many letters were there to begin with that I could pick from, right? Would be this type of question. Well, how would you find that out? You could just guess and check. You could go 2p2, 3p2, 4p2, 5p2 till you get to 42. But what they did on the diploma in the past is they'll say whatever makes an error, dude makes an error some way along the lines when he solves for this, where did he make his error? So if you only know how to go 2p2, 3p2, 4p2, 5p2, then you'd be like, well, he just didn't punch it in like I did, but that's not an answer, so I can't do it. So we have to simplify this side first. The n factorial is bigger than the n minus 2. So we expand the n factorial out. N, 1 less is n minus 1. 1 less is n minus 2 factorial. We can stop at the factorial because the bottom has a factorial. Equals 42. Now your n minus 2's cancel. So I'm left with n times n minus 1 equals 42. The only way you can solve for a variable when you're solving is, remember, you get it equal to 0 if you have an n squared or something like that. If you have just an n, you can just solve for it. But actually, in this case, we'd have to expand this out first. So we're going to have n squared minus n equals 42. And remember, the moment you have a squared with another variable, you're going to move everything to one side, set it equal to 0, and factor a quadratic formula. In this case, it'll be factoring. N squared minus n, move the 42 over, so subtract 42. And you say, what times what gets me negative 42, and what plus what gets me negative 1? So it's negative 7 and positive 6. Like I said, if you're not good at factoring, please come in and get help because you're going to need to be good at factoring. So when you factor this, you're going to get n minus 7, n plus 6. We don't have to do decomp because there's a 1 in front of the n squared. And then you solve each separately. N minus 7 equals 0. N plus 6 equals 0. Add 7. N equals 7. Subtract 6. N equals negative 6. This is all from grade 11, these last steps here. Now I put a slash through n equals negative 6. So I'm telling you that n can't equal negative 6. Why can't it? Think about your answer has to actually work in the question, correct? No. Something to do with the factorial symbol. You have an n factorial on the top, correct? So technically you'd say if you could take that negative 6, you could plug it in and check it to see if it worked, right? You can always check your answers into a question. If I plug a negative 6 back in here, if you try and find negative 6 factorial, you can't. Well, remember what the factorial symbol does is it takes you from that number, so say it's 10 factorial, and you go down by 1 till you hit 1, right? 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Do we ever get into the negatives? No. So how could you do negative 6 factorial? Would you, if you subtract 1 from negative 6, you're going to get to negative 7, negative 8, negative 9. Will you ever reach 1? No, you're going the wrong way. So you can't ever do factorials of negative numbers. So if you plug this back in and you get a negative factorial, so I get negative 6 factorial or negative 8 factorial, I can't use that one. But if I try the 7, there'll be 7 factorial over 5 factorial. 7 factorial over 5 factorial is 42. So you can actually check your answers on these and see if it works. So you have 8p3 where you could fill it in to your calculator, right? And you can go 8p3 in your calculator. And we'd go, oh, I got rid of my calculator. What's 8p3? How much is it? 3. Okay, 336. Now, we can also find that using the 8 Npr formula. So this is the Npr formula. It's given to you on your formula sheet. It's under Perms, Coms, and Binom theorem. They even titled it. So everything from this unit is under that one little box in the bottom. So every place we have an n, we're going to replace it with 8. So NPR, right? So it's going to be 8p3. So any place we have an n, we're going to replace it with 8. Any place we have an r, we're going to replace it with 3 in that formula. Okay? So we're going to get it equals 8 factorial, because that's n, over 8 minus 3 factorial. So it's going to be 8 factorial over 5 factorial. Now you could type those into your calculator, or which one's bigger? 8 technically, right? So you could do this if you really want to. I don't know if it'd be any faster, but if you were calculator taken away, you'd have to do it this way. You could go 8 times 7 times 6 times 5 factorial technically, right? Over 5 factorial. So it's just 8 times 7 times 6, which is 336. And remember when we did fundamental counting principle yesterday, when I told you when it was 8p3, you would have 3 blanks and you'd start off at 8, then 7, then 6. This is why. That's how it works in the formula. Now, why do we need this formula if we can just use our calculator? Great question. So here's why. You're given something like this, n minus 1 p2 equals 90. You're going to have to use your formula to solve for it. So the formula is NPR equals n factorial over n minus r factorial. So this is what we're going to fill in for n. This is what we're going to fill in for r. So the n minus 1 we're going to fill in for n. The 2 we're going to fill in for r. And then we're going to set it equal to this number, 90. My smartboard's a little off. It's supposed to be circled. So we're going to get n factorial, which is n minus 1. N is n minus 1, and then we put a factorial symbol, over n, which is n minus 1, minus r, and r is 2. Factorial equals 90. Now we can put the bottom together. So we get n minus 1 factorial over n minus 3 factorial equals 90. You try it out. So when we expand that out, we're going to get n minus 1, n minus 2, n minus 3 factorial over n minus 3 factorial equals 90. Those cancel, and you're left with n minus 1 times n minus 2 equals 90. You FOIL these, so you get n squared minus 1n minus 2n is minus 3n plus 2n equals 90. Move the 90 over, n squared minus 3n minus 78, 88 equals 0. And is it 8 and 11? N minus 11, n plus 8, n equals 11, n equals negative 8. That's not possible. So n equals 11. I want you to try C and D. D, I'm going to let you look for 1 second so I can help you out here. D is a little harder because we have this n minus 1 sitting over here. The way to move it over is I could divide it, correct? So I could go n plus 1 factorial over n minus 2 factorial. And then what would join that would be the n minus 1 because I divided over equals 20, correct? Now, could I make this n minus 1 join this n minus 2 factorial? What's n minus 1 times n minus 2 factorial? Just n minus 1 factorial. Because if I went n minus 1 times n minus 2, and n minus 2 factorial keeps going, times n minus 3 times n minus 4 times n minus 5 times n minus 6, correct? It would just be n minus 1 factorial. If you didn't spot that, it wouldn't be the end of the world because you'd still expand this one out. You'd expand it out as n plus 1 and n minus 1, then you'd cancel that off, n minus 2 factorial, then you'd cancel that off. So if you didn't spot that you could put these together, you'd still spot that you could cancel them, and you'd be okay. So try these two out, C and D. Okay, so this one over here, the bigger one is n plus 2, so we'll expand out n plus 2, n plus 1, n factorial over n factorial equals 12. Just cancel. You're left with n squared plus 2n plus 1n plus 2 equals 12. N squared plus 3n. Subtract the 12 over so you get negative 10. When you factor it, what times what gets me negative 10 and what plus what gets me 3? It's n plus 5 and n minus 2. So n equals negative 5 and n equals 2. Let me try this one out. So we'll get n plus 1, n minus 1 factorial over n minus 1 factorial equals 20. They cancel. Expand it out so you get n squared plus n equals 20. And you distribute. Move the 20 over by subtracting it. N squared plus n minus 20 equals 0. And then when you factor that, you say what times what gets me negative 20. What plus what equals 1. And so it's going to be positive 5 and negative 4 would work for both lengths. And because there's a 1 in front, you don't have to do decomp. So n plus 5, n minus 4 equals 0. Solve it out. This will be n equals negative 5, which can't. And this will be n equals 4. Alrighty. So I'm going to get you the same page we were on before, so 524. Number 7. And then these two. So these you're going to actually have to physically put into the formula, right? The NPR formula. I'll help you out with this one first, because this one's kind of hard. So the n factorial and the 84 stay. And then this gets filled into the NPR formula. So this goes in for n and this goes in for r. So it goes n factorial. So n is n minus 2 factorial over n, which is n minus 2 minus r. So minus n minus 4. So everyone does this factorial because it's n minus r, correct? Where people error is doing what I just did. It's minus r. Am I subtracting r right now? Nope. But now I'm subtracting r. I was only subtracting part of r before. If r is more than one term, if r is a binomial, you have to remember to distribute that subtraction sign into both terms. And that's where people error. So if you would have been that person, I would star this in my notes and say I would error here. Okay? So technically you'd have n factorial over 84 equals n minus 2 factorial over n minus 2 minus n plus 4 factorial, because you have to distribute that negative in. So you get n factorial over 84 equals n minus 2 factorial over n and n cancel. Negative 2 plus 4 is just 2 factorial. What's 2 factorial? 2. So do I have to write 2 factorial? No. I could just write 2 because 2 factorial is 2. And then you're going to have to cross multiply. Bring that up. Bring that up. Try those out. So you do number 7 on page 524 and this for homework for Monday.